Welcome back to Part 11 of Introduction to Inference, Chapter 14 and 15. In the last segment, we did a right-tailed test using the p-value method. Now we're going to do a left-tailed test. So let's look at example 2. A car manufacturer wants to test the claim that the average mile per gallon of a rival car manufacturer gets mileage less than 31 miles per gallon. Now we're going to assume all the assumptions are met here. And we have a sample of 40 where the sample mean was 30.81. So first off, we state the null and alternative hypothesis. The null hypothesis would be that the mean equals 31. We're trying to show or prove that the mean is smaller than 31, is less than 31. We're going to assume, if it's not said, we're going to assume the significance level of 0.05. That there was a sample of 40 and the sample mean was 30.81 with a sample standard deviation of 0.5. So with that, we can calculate our test statistic. So we say our null hypothesis distribution is 31, has a mean of 31. It's normally distributed because our sample size is 30 or more. So it's approximately normally distributed with a mean of 31 and a standard error of 0.5 divided by the square root of 40. So we have to see where this sample mean of 30.81, where it lies in this null hypothesis distribution. So we calculate that test statistic, Z0. So we take our sample mean, 30.81, minus the mean of the null hypothesis distribution, which is our sample mean, which is 30.81, minus the mean of the null hypothesis distribution, which is 31, and divided by the standard error, 0.5 divided by the square root of the sample size, which was 40. So we get a test statistic of negative 2.40. Not looking real good for the null hypothesis distribution to be that far out in the tail end, but let's see where it compares to our significance level. For a left-tailed test to find the p-value, we find the probability that our test statistic is less than, our z is less than the test statistic. So the p-value of negative 2.40, I look at my table A and I look up negative 2.40, and that corresponding probability is my p-value. So the p-value is 0.0082. So our p-value is much less than our significance level. So in part 5, we make the decision to reject the null hypothesis. So our conclusion would be we have sufficient evidence at the significance level of 0.05 that the population mean of the competitor's car is less than 31 miles per gallon. Now it's time to look at a two-tailed test. A bolt manufacturer suspects that the average diameter of its bolts differs from 10 millimeters. We're going to take a sample of 100 and the mean will be calculated the mean is calculated as 9.87, and the standard deviation, the population standard deviation, is given to us as at 0.7 millimeters. You don't see that in the very top thing, but it was given to us in the problem. We're going to assume that. So to get the null and alternative hypothesis, we say, okay, we begin by saying, okay, the bolt diameter is 10 millimeters. We're trying to show that it's different. It's different from that. So it's the two-tailed test, that mu just doesn't equal 10 millimeters. Our significance level is 0.05. If you don't see it, then that's what we assume it to be. So now we have to calculate our test statistic. Well, first you have to know what the null hypothesis distribution is. Well, it's the sampling distribution of the sample mean for samples of size 100. The mean our sampling distribution is normally distributed since our sample size is 30 or more. We can evoke the central limit theorem. So our sampling distribution is approximately normal with a mean of 10 and a standard error of 0.7 divided by the square root of 100. So we now can calculate that test statistics. Remember what that is, how many standard deviation that sample mean, 9.87, is in the null hypothesis distribution. Again, where the null hypothesis distribution is the sampling distribution, that's approximately normal with a mean of 10 and a standard error of 0.7 divided by the square root of 100. And we calculate the test statistic to be negative 1.86. That p-value, you have two different methods you have a couple of different methods to look at, but it's 2 times the probability that our z is greater than the absolute value of our test statistic. Or it could have been 2 times the probability that our z is less than the negative absolute value of our test statistic. So we could make our test statistic be negative by taking the absolute value and then taking the negative of it, and then we just look right at table A, or we always make the test statistic positive with the statement the probability that Z is greater than the absolute value of our test statistic, and find the probability. Once we find that probability, we multiply it by 2. So in this case, we're going to take the what we see in the slide is we take the absolute value of 1.86. So we're trying to find the probability that Z is greater than the absolute value of negative 1.86. So that's the probability that Z is greater than 1.86. We find that probability, then we have to multiply it by 2, and that gives us the p-value. So our p-value is 0.0628. So 0.0628 is greater than 0.05. So therefore, we do not reject the null hypothesis. So our conclusion would be there is insufficient evidence, or there is not sufficient evidence, however you want to state it, at the 0.05 significance level that the population mean diameter differs from 10. Now it's time to look at how we could use Minitab to help us to calculate these. So let's look at this. A researcher believes that the average height of a woman aged 20 years or older is greater than the 1994 mean height of 63.7 inches on the basis of data reported by the Centers of Disease and Control Prevention. She obtains a random sample of 45 women and finds that the mean height is 63.9. Assume the population standard deviation is 3.5 inches. Test the researcher's belief that the p-value, using the p-value approach, for a significance level of 0.05. So we have our null and alternative. Mu naught equals 63.7, that the heights have increased, have gotten greater, so it's a right-tailed test. So our alternative would be that mu is greater than 63.7. Our alpha is at 0.05, and we're going to let Minitab do our test statistic, and this is how we would do it. Here's the command. You would do 1Z, that's a one sample Z test. You put in the sample size, see the 45 is our sample size, and the sample mean of 63.9. Put a semicolon, because now we've got to let Minitab know what our null hypothesis distribution mean is and what our sigma is. And then we also have to let it know are we in a right, left, or two-tailed test. So the next line is a subcommand where we let it know what the population standard deviation is. It's 3.5. So we say sigma 3.5. Minitab will then convert that population standard deviation to the standard error. It will internally say 3.5 divided by the square root of 45. We don't have to do that calculation. Minitab does it for us. Then we have to let it know what is the value of our null hypothesis. What's the mean? So we put test, and then we put the mu naught, the value in our null hypothesis, which was 63.7. Then we have to let Minitab know whether it's a left, right, or a two-tailed test. For a right-tailed test, we say alternative, or you could just write the first 4 letters of the command, alt, A-L-T-E, or alternative. Alternative 1 means a right-tailed test. Alternative 0 would mean a two-tailed test, and alternative -1 would mean a left-tailed test. Since this is a right-tailed test, we say alternative 1. Then we end our subcommand, hit enter, and Minitab gives out this result. So we see here, it gives us the sample size of 45. It puts down what the mean is, and it gives us our test statistic. It's 0.38. And with the 0.38, the p-value is 0.351. Since the p-value is much greater than our alpha, we do not reject the null hypothesis. So our conclusion would be there's not sufficient evidence, or there's insufficient evidence at a 0.05 significance level to support the researcher's belief. And you could even go in there that the height has increased from 63.9. This is the this is the command, the general command for Minitab. Ends part 11, and we will continue with hypothesis testing in part 12.